Hello class, welcome to the next Eureka Math 8th grade Module 3 lesson. We're doing lesson 2 today, all about dilation properties. So you will need pages 13 through 25 of your Module 3 book. Let's talk about the road so far. What did we do in lesson 1? Well, in lesson 1, we started talking about dilations. And we learned about a dilation is a transformation. Now in Module 2, we learned about the transformations called rigid transformations. Those were translations, reflections, and rotations. And those three rigid transformations did not change size, did not change shape. They kept things congruent, just in different locations. A dilation is a different transformation because a dilation does change the size, but it keeps the same shape. So dilation is not a rigid transformation because the size changes, but the shape stays the same. It is still the exact same shape, just a different size. That's a dilation. And just like all transformations, we talk about how dilations follow rules. Like a translation follows a vector, a reflection follows a line, a rotation does points and degrees. A dilation uses what we call scale factors. The scale factor is what tells us how much the size changes. So, and remember, it is a scale factor. Factor means multiply. So we multiply by the scale factor. That's why the word factors in there, in case you're curious. The name scale factor tells you that you need to multiply. That tells us how much the size changes. The other part of the dilation rule is the center, and the center shows us where the dilation is happening. So the scale factor tells us how much, the center tells us where. And we will see in today's lesson how those two things work together to change a shape. So if that's a little confusing, we're going to practice dilations today. It should be more clear after today. Scale factors. A note about the scale factors. A dilation with a scale factor less than 1 is a decrease in size. A dilation with a scale factor greater than 1 increases the size. So that's a couple tricks to remember to help you know if the figure is growing or if the figure is shrinking. You need to look at the scale factor. Bigger than 1, the figure is growing. Smaller scale factor, smaller than 1, the figure is shrinking. And we'll see both of those today in this lesson. We'll make figures grow, we'll make figures shrink. Because today I am going to show you how to draw dilations, and we will also observe some properties of dilations. So today we're showing you how to draw, how to do it. So we are going to be precise. So it might help you to get your colored pencils, or I use colored pens, out to help you. You will also need a ruler today to help you, a ruler with measurements on it to help you with the dilations today, because I'm going to show you how to actually draw them. So today we're going to practice being precise. We're going to practice paying attention to detail and making sure that we have the most specific answer we can get. And then we're also going to talk, after we draw these things, we're going to talk about properties of dilation. And we're actually going to talk about 2 properties of dilation. So you'll see I have them numbered 1 and 2. I'm leaving them blank right now, but we will fill them in at the end of the lesson. We will fill in the 2 properties we learn at the end. So those are the notes that we're going to start with. In just a minute, we're going to go through some examples, and I'm going to show you how to draw dilations, and we're going to talk about what we learned from those drawings. But right now, I'd like you to pause the video, take a little bit of a break, make sure all your notes are filled in, make sure you have the materials you need, including, remember, the ruler. Once you have all your materials and your ruler and you're ready to work, you can unpause the video and we will get started. Okay, class, you should have gone back and checked your notes. You should have got all your materials ready to go. And we are ready to get started on lesson 2, dilation properties. Let's start with page 13. Top of the page looks like that. But we are probably more interested in this figure right there. You can see that we have a line L. And we have this O is the center. What we are going to do for this is we're going to practice dilating. Now, if you'll notice in the directions, they do not tell us how much to dilate, so we get to practice a little bit ourselves. But let's go through the steps of dilation. First step, I'll do the steps down at the bottom a little bit. Here we go. That's our figure. Step 1, we locate the figure and the center. So the center here is O, and the figure is a line. We found it. Step 2, we draw rays from the center through points on the figure. Now, the reason we do this is because, remember, the center shows us direction. The center shows us direction. So we need to use the center and the points to show what direction the figure dilates. So you start at the center and you connect the point. So I'm going to connect the center with point Q, and I'm going to draw a ray starting from the center, going through point Q and beyond. And I'm going to do the same thing starting at the center, going through point P and beyond. So that's the direction that the dilation is going to go. That tells us the direction the dilation is going to go. So if we look at that, we know the dilation is going to move in that direction. So when the line grows, it's going to grow that following those lines. Let me show you. Step 3, identify a scale factor. Now, for this one, the question did not give us a scale factor, so I'm just going to pick one. I'm going to say R equals 2. 2 is an easy number to multiply by, so I'm going to say the scale factor is R equals 2. Now, to do R equals 2, I need to actually find the original lengths. So the original length, let's see, what is OP? Let's use centimeters, because centimeters are a little bit easier to do with multiplication. If I'm looking at that, and you can see, it looks like OP is 2.4 centimeters. 2 and then 4 more ticks means 2.4 centimeters. So this is 2.4 centimeters. OQ looks like it's 3.8 centimeters. 3.8 centimeters. Now, that is what I know. Now I know everything. I'm ready to dilate. So identify the scale factor with step 3. Step 4, find original distances. Step 5, dilate. Step 5 will be dilate. So the scale factor is 2. We found the original distances. Now we need to dilate. So if the scale factor is 2, the original was 2.4. So remember, OP is 2.4. So OP prime is going to be R times 2.4, because that's the R factor is how much it changes. So the original was 2.4. The new one, prime, is going to be the scale factor times 2.4, which is 2 times 2.4. So OP prime is going to be 4.8 centimeters. So that's where the new one is going to be. So on my diagram, I'm going to get my ruler again, and this time instead of being 2.4, I'm going to put a point at 4.8, which is right here. That's going to be P prime. And if you look, you can even look with your eyes, and you can see this looks double the length. This was the original. This is the new. Original, new. It's twice as far. The reason it's twice as far is because the scale factor is 2, twice. And we do the same thing for OQ. Oh, I should label this. OP was 2.4. OP prime, remember, is 4.8 centimeters. And we do the same thing for OQ. OQ, the original, was 3.8 centimeters. You can see it right here. The new one after the dilation, OQ prime, is going to be the scale factor times 3.8. Remember, the scale factor was 2, so we do 2 times 3.8, which means the new point after the dilation, after it doubles the length, is going to be 7.6 centimeters. 7.6 centimeters. So I need to add that to my diagram. So now, instead of stopping at 3.8, I'm going to keep going to 7.6 right here. And that is Q prime. And Q prime is 7.6 centimeters away. Now, I'm not done with the dilation yet, because I remember I'm not dilating points. Remember, I had to locate my figure. The figure I'm dilating is the line. Moving the points just helps me find the line. The way that I finish finding the line is I connect my 2 points. And that's the new line. In fact, I can say this is line L prime because it happened after the dilation. So you can see that is an example of how we dilate. We find what we're dilating, the line, we find the center, we draw rays connecting some points, we find the scale factor, and then we multiply the original by the scale factor to find where the points move to. So Q gets multiplied by 2 and moves up here. P gets multiplied by 2, moves up here. And then we connect them, and that's the new line. So we dilate by moving points. Just like that. So hopefully you follow along with me. Hopefully you know what you're doing with this. Take a minute, pause the video, catch up, go back if you need to see it again, and make sure that I'm going to give you some time right now to catch up. I might have moved a little bit fast, but I want your diagram to match mine. Exactly. Your diagram should match mine Exactly. So pause the video, take a couple minutes, go back and watch me do it again, and make sure your diagram matches mine. Okay, class, hopefully you're all caught up and your paper looks like mine with the dilation in the exact same place. We dilated by 2. And so the line L turns into line L prime, and it is twice as far away from the center. So it moves away from the center because the center gives us the direction. And it's twice as far because the R factor, the scale factor, was 2. So let's look and keep practicing a couple more times. Go to page 14. Look at example 3, I'm sorry. Where we have a center, we have a line, and we have to map the line to the line. So this is going to be a little bit of a tricky one, because if you look at this, the center is actually on the figure that we are supposed to dilate, which means the center is on the figure. So let me show you what happens. We're still, so step 1, I found the figure and the center. The figure is line L, the center is O. Step 2, draw rays that connect the center with points on the figure. So the rays, this is going to be a little bit freaky maybe. The rays actually go in this direction. That's one of the rays, because the rays just have to connect. So if you look, the rays stay on the line. So it looks like the line is just going to grow wider, not really move anywhere. That's what's going to happen. The line's going to grow wider, but not really move anywhere. Because if now, let's say R factor, let's say this time let's do R equals 3. So the scale factor is going to be 3. Let's find our originals. So OP original looks like it is 1.6. 1.6 centimeters. OQ looks like it's 2.5 centimeters. Now the new ones, remember the R factor is 3. So OP prime is going to be R times OP. And OQ prime is going to equal R times the original OQ. So we know the R is 3 and OP was 1.6. So that means OP prime, the new one, is going to be 4.8 centimeters. OQ prime is R times the original. R I gave you was 3, and the original was 2.5. So the new one, the image after the dilation, 3 times 2.5 is 7.5 centimeters. Following the vectors we made, following the rays. Now, because the center is on the line, we just follow the lines that way. So OP prime has to be 4.8. So it moves this direction. So OP prime is going to be, P prime will be right there, 4.8 away from the center. Q prime is going to be 7.5 away from the center, which is right here. That's Q prime. You see there's measurement involved here. You have to measure precisely, you have to multiply, and you have to label precisely. So OP was 1.6, OP prime 4.8 centimeters. OQ is 2.5. OQ prime is 7.5 centimeters. That's what the dilation looks like. It just stays on the same line. In our first example, the line moved because the center was away from the figure. In example 3, the line stayed it's all stayed on the same line because the center was on the line. But if you look, what they're showing you on this is that a line after a dilation turns into a line. A line after dilation is a line. And on this one, a line after dilation is still a line. What they want to show you with this is that the shape does not change, which is actually the first property we're going to talk about. So going back to our note page on the bottom of our notes, I told you we're going to talk about 2 properties today. The first one, we're going to say dilations map lines into lines, points into points, and segments into segments. In other words, the figure does not change. If you dilate a line, you're going to make a line. If you dilate a point, it's going to make a point. If you dilate a segment, it's going to make a segment. If you dilate a star, it's going to make a star. If you dilate a trapezoid, it's going to make a trapezoid. If you dilate a picture of a puppy, you're going to get a picture of a puppy. Dilations do not change the shape. They change the size. They change the size. You know they change the size because look how much bigger the distance is. Look at that distance. This distance is bigger than this distance. The points are farther apart, so the size changed. And if you look at example 3, this was the original size, but then after the dilation, the size changed. It grew, so size change. So the size changes, but our first property tells us that the shape does not change. That's really what they're telling. That's really what they wanted you to see. They wanted you to get some practice using your ruler and being precise, and they wanted you to see that the shape does not change, just the size. So that is the first property. Let's move on. Let's keep working on page 14. The exercise where we have a triangle, and we're going to dilate this triangle. Now let's look at the directions. This time they give us directions. They say, given center O and triangle ABC. So they told us the figure, they told us the center, so that's step 1. Dilate the triangle from center O with a scale factor of R equals 3. So this time they told us the scale factor. We're going to do R equals 3. So here we go. We know the scale factor. We know our figures. We know our center. The first thing we need to do is find the direction. So to find the direction, we're going to connect all of the 3 points of our triangle with the center and draw rays. So this is the first thing that we need to do. We need to show what direction everything is moving in by drawing some rays. So that is what yours should look like right now. You should copy mine exactly. You have them connected. So now we know what direction we're going. And we know that R equals 3. R equals 3. So we have direction and we know how far. Now we need our measurements. So let's get our rulers and let's find the measurements. Let's do OA first. OA, oh, it's a nice whole number. OA is 3 centimeters. So OA is going to be 3. OA equals 3. OB, that's a nice even number. It's like they planned this to make our lives better. Because OB is going to be 4. Let's see if it's still nice to us with OC. Not as nice. It looks like OC is going to be, looks like it's about 3.6. 3.6 centimeters. So OC equals 3.6. So we know the originals. We know what direction we're moving. Now it's just the math. Now it's just multiplying by the scale factor. So if OA is 3 and the scale factor is 3, that means it grows 3 times 3. So A prime is going to be at 9. Here is A prime. And OA prime equals 9 because 3 times 3 makes 9. OB was 4. So B prime, we're going to multiply by 3 again because that's the scale factor. B prime is going to be at 12 because 4 times 3 makes 12. So that's B prime, and OB prime equals 12. This one might be a little bit tricky because it's 3.6. You have to do 3.6 times 3. Which is, let's see if I can do it in my head, OC prime, 3.6 times 3 is going to be 10.8. 10.8. And it looks like I made my ray just long enough. So here is C prime. So there we go. That was the first thing I did is I drew my rays. I drew the pink lines first. And then I did my math with the green right here. This is my math. I did 3 times 3, 4 times 3, and 3.6 times 3 to get my answers. And then I put points where they go. I'm not done yet because remember, the instructions were to dilate the triangle. Dilate the triangle. So I need to show you what the triangle looks like. So I need to connect all my points, all my prime points, to show you what the triangle is like. And there it is. That's triangle ABC prime. And I know that triangle ABC prime is exactly 3 times bigger than the triangle ABC. The reason I know it is exactly 3 times bigger is because the scale factor was 3. We can even check it if you like, because all the pieces should be 3 times bigger. So this segment right here, AC, segment AC is 3 centimeters long, which means this segment right here should be 9 centimeters long. And look at that. It is 9 centimeters long. It is 3 times longer. Segment AB is about 2 centimeters. So segment A prime, B prime should be about 6 centimeters. Segment BC is about, looks like about 1.8, maybe 1.7. So 1.7 times 3, we should get about 5.1. And this looks like it is pretty close to 5.1. Everything is 3 times bigger. because the scale factor was 3. It's still triangle. A triangle turns into a triangle. It just changes size. That's a dilation. And if you look, part A at the bottom is saying it's still made of segments. So a segment dilates to make a segment. A segment dilates to make a segment. A segment dilates to make a segment. So the shapes are the same. It's still a triangle. Triangle is in fact, looks like it's exactly the same, except it's bigger. So that goes back to the first property we were just talking about. Dilations map lines into lines, points into points, and segments into segments. The shape stays the same, only the size changes. So that is exactly how you dilate something to make it bigger. Hopefully you follow along with me. You did your raise, you measured precisely, you multiplied to do the math, and your new triangle looks just like that. Let's move on to page 15. They have more questions. Actually, this stuff is what we just kind of did. They say measure the length of the segment, and I did that. Remember I said segment AB was 3 and segment AB prime is 9. So we did that already. So we said AB equals 3, A prime B prime equals 9. Why is that? Because R equaled 3. The scale factor is 3, so we multiplied by 3. And part C is just what we also already did, just as verify the claim you made in part B by measuring BC and B prime C prime and CA and C prime A prime. We already did that. I showed you that everything changed the same amount. The scale factor changed everything. At least it almost changed everything. Because looking at part D, it's asking us to look at the angles. To look at the angles. And then what do you notice about the measure of the angles? So we know the sides, the segments, changed size. We know the segments got multiplied by 3. But what about the angles? Did the angles also get multiplied by 3? Now, some people will say, yes, the angles did get multiplied by 3 because the R factor must have changed them. Well, let's measure to find out. Now, I know a lot of you do not have protractors, so I'm going to show you a little trick to compare the angles by using the transparency, because I know you have the transparency. So these are the 2 triangles we made. What I'm going to do is I'm going to copy the original triangle onto my transparency. And I'm going to label so that we make sure I stay the same. Now I want you to see something, and remember, I don't care about the size of the sides. Right now I only care about the size of the angles. If I move my little triangle up here, what do you see about angle C? Here's angle C down here. Angle C is where the C is. If you look at angle C and C prime are exactly the same. The angle C is the same as angle C prime. So the scale factor did not change the angle. Let's double check with angle A. Here's angle A. Move it down here and look, angle A and angle A prime line up exactly. The scale factor did not change the angles. Let's double check with B. Here's angle B. If I line it up over here with the new one, the angle lines up exactly. So the angle size did not change. Now, obviously, the sides did change. But also, obviously, you can see that the angles do not change. So that's the other property we're talking about today. Number two, property number two, dilation does not change the degrees of angles. Yes, it changes the size of the sides, but it does not change the degrees of the angles. It makes the shapes bigger, but the angles stay the same. That's a little trick that not a lot of people would guess. You would think that if a dilation makes the shape bigger, then it would make everything bigger. But it doesn't. The angles stay the same. Because remember, an angle is just like a ratio. So even though the sides get bigger, the ratio between the sides stays the same. So because the ratio stays the same, the angle, the degrees stay the same. So that's a little bit of a trick, a little bit something you might not have known, or you might have gotten wrong if I asked you yesterday. But today you know that dilations, part one, the shapes stay the same. And part two, the degrees of angles stay the same even if the sides change. So that's our second property for today. And that was part D and E asked us to measure all the angles and to see what we noticed. So you should have noticed that the angles are the same. So what do you notice? Angle degrees were the same. And this right here, it was the same answer. And we learned property 2 in your notes. That is property 2 in your notes, part E. Just asking you to summarize that. So that, I think, might be all the activities we have for today. Let me check. Going to page 16. Yep, page 16 is the lesson summary, which is actually just the lesson summary is the two properties we talked about. Dilations map lines to lines, rays to rays, and segments to segments. And dilations map angles to angles of the same degree. So degrees stay the same. So shape stays the same, degrees stay the same. We can summarize shape and degrees stay the same. But obviously, you should also remember size does not. And that's the lesson for today. What I'm going to do is I'm going to take a little bit of a break so that because I've been talking for a while and I need a drink of water. But so you can go back, check your work, make sure you are not missing anything. And if you need to watch any part of the video again, watch the video again. When you're done checking your work, checking your notes, and you're ready to move on, you can come back to the video, unpause the video, and I will talk to you about the problem set and the exit ticket for today. So take a minute just to go back and catch up, and I will see you when you are done. Okay, so that's the lesson summary. Hopefully you've all caught up with your notes and everything. We are ready to talk about the problem set and the exit ticket right now. Page 17 is the exit ticket. That's going to be the page 19. Now here's the homework helper is actually a few pages, which means they give you a lot of help. They give you some example problems. They even show you a dilation, and this is actually a good one because what they did for this one right here, number 1, they dilated by r equals 1/4. Now we did dilations bigger than 1 where the shapes grew. This homework helper is the dilation scale factor less than 1. So they actually took the figure and they shrank it down. So if you want some guidance about how to shrink a figure, look at homework helper number 1. They show you how to shrink it. Number 2, they show you how to do it with the scale factor r equals 3. So they show you how to make it grow And then homework helper on page 21, they give you more help where they are talking about dilating it from two different centers. So you look, they have two centers. So they dilate it one time to make it grow this way, and they dilate another time to make it grow this way. So from two centers, then you can see, well, these are the same size because the scale factor for both was 2. So look at the homework helper if it helps you. And there's homework helper on page 22 where they're finishing that one, and they're just talking about how you can just use a translation to move one onto the other. So the homework helper is useful. But let's talk about the problem set. So that right now, number 1 on the problem set says use a ruler, which is how I show you, to dilate the following figure from center O, and center O is down here, with the scale factor R equals 1/2. Which means the scale factor is less than 1, so you are shrinking this. So this is a quadrilateral that you are making smaller. So remember, homework helper number 1. Homework helper number 1 will show you how to do that. We'll show you how to shrink it. For number 2 on the problem set, page 24, says use a compass. I would just say use your ruler because not everyone has a compass. But this time the R factor is R equals 2. And wait a second, this time there are 2 centers. So they're going to want you to dilate this one twice. They're going to want you to dilate it with R equals 2 times. So you're going to use this center first and do R equals 2. And then you're going to do it all over again, this center, R equals 2. Then you're going to see, and then you're going to, so that's the first thing you're going to do. You're going to do 2 dilations. 2 dilations, and then part B says, what rigid motion would move your dilations on top of each other? So how do you make, so dilate this center first, then dilate this center, and then you're going to get 2 figures up here. How do you put them on top of each other? Page 25, the last page of the problem set, you're going to dilate the triangle from center O. Scale factor is 1/4, so it's less than 1, so you're shrinking the triangle. So just shrink the triangle following the same steps we did together in class. And then it's asking you number 4 and 5, the last 2 questions of the problem set are just summarizing the properties that we learned today. So number 4 is connected with property 1. Number 5 is connected with property 2. You can do that. So you're going to do the problem set, and remember my answers to the problem set are posted on the Google Classroom, so you can check your answers with mine. Please check your answers with mine, and please ask me questions if you are confused. Send me an email, send me a message some other way. Ask me during the class meeting, and I will talk you through about how to do anything you have a question about. So check your work with mine, ask me questions, and then when you are ready, get your exit ticket out again. It was page 17, and it's asking you to test to see how skilled you are. Now, my answers to the exit ticket are not online, but if you do the problem set and you have no questions about the problem set, the exit ticket should be easier. So this one is center O and quadrilateral. Using a ruler, dilate it. Scale factor is R equals 2. So dilate and label. You're going to make this bigger. And then number 2, describe what you learned today about what happens to lines, segments, rays, and angles after a dilation. So summarize the properties. Summarize the properties you learned today. Just summarize the big idea of the lesson. And that's your exit ticket. 1 question and a summary of the big ideas. Please check your work on the problem set. Please ask questions. Get the exit ticket done. Take a picture of it. Turn it in on the Google Classroom. And I will see you for lesson 3 next time. Have a great day.